in this session. So once again, welcome everyone to our LISA 2020 plenary session. Today's event is a session on new approaches to statistical learning in developing countries. And I will just say a couple words that this is one of our plenary events for the LISA 2020 Symposium. And LISA 2020 is a network of statistics and data science collaboration laboratories that are centered in developing countries. The idea behind LISA 2020 is that these stat labs that are members of our network are building statistical analysis and data science capacity in their local institutions, and developing capacity to transform evidence into action in their local communities, in their countries, and with our network, we can collaborate globally on global problems as well. And so the point of the LISA 2020 Symposium is to learn, so there's several reasons that we're having the symposium. One is to sharpen the skills of our network members and anyone else who is attending. But then the primary reason is to share best practices between stat labs. So, in today's event, we're going to be hearing about what a few of the stat labs and universities are doing in using statistical learning for research and for teaching. And so we're looking forward to today's event. I'm going to turn it over to Marcus, and I will make Marcus the co-host. And so we ask that you mute your microphone. Unless you are asking a question or making a comment, then unmute yourself. But we want to keep the background noise to a minimum. So Marcus, go ahead.
Good morning, everyone. So I am Marcus, and I think I didn't say this to Eric, but I asked Dr. Asifa to be the chair of the session. So I was expecting her to introduce our speakers. I'll just say some few words before her. So this session is based on a chapter of our upcoming book, a book from LISA 2020 network, and specifically is from chapter 8, New Approaches to Statistical Learning in Developing Countries. The book is being organized by Olawale Ale from Nigeria, and he asked me to organize one of these chapters. So I am the organizer of this specific chapter about statistical learning. So today we will have 3 speakers. In order will be Leonardo from Brazil, me from Brazil too, and Adenomon from Nigeria. But I will ask Asifa, since she is the chair of the session, to introduce us. You can go, Asifa. Thanks.
Marcos?
Yes, Leonardo?
Sorry for the last minute request. Can we change the order just because I have some background noise here and Eric was talking about this. We try to reduce it, right? And I'm a guy who has kids around in the pandemics. Mm-hmm. So if someone could take the first session, it would help me, okay?
Sure, no problem. I can be the first.
Okay, thanks.
Thank you, Professor Marcus, for giving me an opportunity to chair the session. This session is organized in the context of LISA 2020 third symposium to discuss the new approaches to statistical learning in developing countries. Statistical learning is an area of knowledge that uses statistics and computer science tools for understanding and modeling data. There are many free resources such as computer softwares and data sources to help anyone who wants to teach this subject in developing countries. We will show in this session through different examples by different speakers how statistical educators can take advantage of some of these resources to prepare the students for the changes that are already happening in the statistical world. First of all, I will share with you some experiences of mine, because I also belong to developing countries. So what I face is that uh, it is about the subject statistics. But it is seems like a daunting subject. Students do not like to study probability, particularly some inference. So how can we improve our teaching or learning in statistics by using modern technologies? There are also gaps. We are teaching pure theory without application, and universities in developing countries cannot afford more software and hardware purchases. There is no cultivation of statistics literacy in primary and junior high schools. Inadaptability of the results, the practical situation, lack of qualified statisticians, lack of data. So I would like that these issues to be addressed in this session. First speaker of this session is Professor Marcus Alexander Nunes. Marcus Nunes holds a PhD in statistics. He is an assistant professor at Federal University of Rio Grande do Norte, Brazil. He has over 10 years of experience in statistical collaboration and teaching statistics. His main research interests are application of statistics and data science to real-world problems in several areas such as ecology, health, and linguistics. So, over to Professor Marcus. Please share your advice for other developing countries. How can we improve our statistical learning using the new approaches? Over to Professor Marcus.
Thank you, Asifa, for your kind introduction. So the way we are thinking to run the session is we have 3 speakers. So each one will talk for like 20 minutes approximately. And at the end, we'll have like a 30-minute session to discussion, okay? So I'll start. And what I'm talking today is it's my part in this chapter of the book, in the book chapter, called Modernizing the Curricula of Statistics Courses Through Statistical Learning. So, well, what I will be doing, this is the, I can't, okay, let me scroll. So, what's the motivation about this talk? The motivation is something we can notice, it's a trend we can notice in the past few years. Nowadays, it's easier than ever to fix complex models to data. We don't need to teach only like a logistic regression or linear regression or t-tests to our students. We can teach them some machine learning models. We can teach them how to gather data instead of just, getting a CSV file from a book or something. So we have many data repositories available for free in the world. We have free software and free data to give our lectures. And today, I want to talk to you how us as statistical educators can take advantage of these new technologies to prepare our students to this new world. My idea didn't come from only like myself, because in 2014, ASA guidelines for statistical courses, they defined, I would say, 4 main areas we as statistical educators could follow to prepare our students for the next years. And these are the four areas they suggest in their guidelines. First, we need to talk to our students about the increased importance of data science. We need to be deeper in data science, a lot more deeper than we were in 2014. We have to teach real applications to our students because the students engage more in our lectures if we are dealing with real data. We need to teach more diverse models and approaches to obtain data or to model the data we obtain. And we need to train our students in their ability to communicate. They need not only express themselves well. I mean, they need, of course, they need to communicate their results well, but they need to talk to their clients or their collaborators to understand what's the problem of other people. So these are the 2014 ASA guidelines. And I read the guidelines in 2014, and in 2015, it was my first year in the university I am right now, Federal University of Rio Grande do Norte in Brazil. So I created a new course, a 4-credit equivalent to a 4-credit course called Introduction to Big Data Modeling. And this course is being offered since 2015 as an elective course to second-year students. So they are in their 4th semester usually, and they only need to know basic statistical inference like t-test, ANOVA, simple linear regression. They don't need to know multiple linear regression for this course, and they need to know some R programming. They have the R programming class in the 3rd semester, so they just finish in 1 semester the R programming, and then they are going to the big data modeling right after the DR course. Oh, sorry, I just have a code here. It should be an image, sorry. It was an image about how data science is increasing over time. I will prepare the figure and show to you later, okay? And the discussion part, sorry about that. So one of the pillars of this introduction to big data modeling is the use of real data sets, because we understand the students will be more engaged with the course if they analyze real data. And there's a paper from Hicks and Irizarry from 2016 that shows from their experience that students are more motivated when they see data collected from the real world. So in our course, Introduction to Big Data Modeling, we have many types of real world data sets. We have Fisher Iris data set that is very simple. Anyone who have learned, I don't know, PCA or some multivariate analysis in statistics field, I think they know Fisher Iris data set. And we have FIFA Soccer data set, a game, a computer game, where we have more than 20,000 different soccer players. And we have lots of information about these players, like their height, their speed, their ability to attack, to defense, and so on. And with this data set, the FIFA Soccer data set, they can run classification models. They can try to predict that given the physical characteristics, the physical attributes of a player, in what part of the field, in defense, midfield, goalie, or a forward, where they will play. So we have many different real world data sets, and the students can apply what they learn in these data sets. Of course, as our course advances, the data sets become more complex, and we have access to many data sets because there are great free sources with interesting data sets. We have websites from governments with free data to analyze. Mainly I use US government and Brazilian government data. So US government has an open data site where you can get data from education, health, economics, and so on. And Brazil has an institute called IBGE in Portuguese, which stands for Brazilian Institute of Geography and Statistics. They run our census every 10 years, and they have lots and lots of data sets open and free to anyone to download. So we are living in a time we can find very, very good sources of data. We have as well private sources of data. Kaggle is a very famous website in the machine learning community. If you don't know, I strongly suggest you to check it out. But Kaggle has lots of data sets, lots of kernels. Kernels is how they call the code to analyze the data. So they have kernels written in R, in Python, and Julia mainly. And a website I use since I was in my PhD 10 years ago is the University of California, Irvine Machine Learning Repository. They have lots of data as well. Sorry, I spoke some Portuguese. Kaggle, for you to get an idea, last year when I teach this class the last time, they had around 18,000 data sets. Last time I checked 1 month ago, they had like 54,000. So we tripled. They had a huge number last year. They tripled in 1 year. So there's lots and lots of data at Kaggle. Besides the real data, at least in Brazil, our courses at the undergraduate level choose to show fewer modeling techniques to the students. Usually here in the statistics courses we have here, and this is not a problem, just let me say this. Usually the students see less models, but they see these models very deep. They know how to prove theorems, they know how to prove everything about these models. So they prove results, they go deep on the math behind them. In our course, Introduction to Big Data Modeling, we prefer to present a lot of models, focusing not on the math behind them, but on their strength and limitations. So instead of going deep on each model, we present a lot of them and show them superficially, but the students are only required to know, to have an intuition how the algorithms work. They don't need to know, for example, how exactly a split in a classification and a regression tree works. They just need to know the splits happens, and usually use something like a Gini index to decide how the split was made. So this is enough for this course. So these are the subjects we see in our course. So we start with clusterization, k-means, hierarchical clustering, and PCA. Then we see something about data acquisition, and this is in orange because it's the case study I'll show to you today. And then they learn cross-validation because usually these models don't have statistical assumptions behind them. So cross-validation is a good tool to evaluate, to try to avoid overfitting in the data. And then k-nearest neighbors, SVM, classification and regression tree, random forests, and we finish with model ensemble, when the students fit many models to their data, many weak models, and they combine these weak models to get a new personalized model that is usually strong. So this is what we see in roughly 15 to 16 weeks. But it's very fast, it's a very fast pace. Our students are evaluated through midterms and a final project. The final project has two parts, a written report and a live presentation. And the live presentation is to evaluate their ability to communication, the oral communication, and the written report, the ability to communicate by a report, writing their findings. Usually, the default for the live presentation is to present slides, like what I'm doing here. But in two opportunities, the students have built dashboards to present their results. And in 2018, one of the groups made a dashboard about soccer players. Soccer is really strong in Brazil. I don't know if you know that, but we like soccer here. And they're presented, they showed their findings in a dashboard using Shiny. It's a package for R. And they submitted their dashboard to a contest held by RStudio, and now their dashboard for this course is featured as one of the examples you can do using Shiny to deal with sports data on the RStudio website. So it's a very they are very proud of their result, and I am very proud of them. So this is like the main idea of this course. And in the next 5 minutes, I hope I don't go much further than 5 minutes. I want to explain one of the things we do in this course to acquire data. This is the case study for web scraping. So this is a project the students have to complete when they are studying web scraping. This is the 5th module of the course. And if you want to know more about web scraping, there's a very nice paper. It was published like 2 or 3 months ago from Doguku and Shantikaya Rundle. And you can learn more about web scraping in this paper. But what is web scraping? It's at the bottom level is to extract data from websites. The data is not organized in a file, it's in a HTML page, and you want to extract this data from websites. There's some gray area there if this is legal or not, but I will not enter in this discussion right now. But it's extract data from websites, and we want to automatically collect and organize this data. And of course, only open data can be reached this way. We cannot use web scraping to get data from banks, for example. It's only data that is there on the internet, open to everyone, and then we can collect. So what's the project they have to do? They have to web scrap Wikipedia. So this is a screenshot from the list of cities in Brazil. They are classified by population. So you have, in Brazil, we have almost 5,600 cities. So it's a lot of cities, and it's nice to have an automatic way to get this data. So this is a list of cities in Brazil by population. Wikipedia in Portuguese has the list of cities in Brazil according to their area. And these are the packages we use in this project. We use 5 different packages in R, but the main package for the web scraping is this one, RVest. And I will show to you the code. I don't expect you to understand or memorize everything, but I want to show to you how simple is this. So you just need to give the link, and then you have a function called read HTML that reads the page. You have a function called HTML table that extracts the table. I show to you the both table from both pages. And then you just need to process this. So you need to, sometimes you have more than one table in the page. So here I'm saying I want the first one. And then you have to rename the columns. Well, you don't need to. I rename because titles are in Portuguese, so I translated to English. So you have this. You have that page in HTML. You have inside of R just like that with 3-4 lines of code. We can do the same for area. I don't show the code, but the result is here. Okay, and notice we have in both data sets, we have this IBG code. This is the code the city gets from our Brazilian Institute from Geography and Statistics. So why this column is important? Because we can use a function called left join. For those who know SQL or SQL, I use this function to combine 2 data sets. So I'm combining population and area by the IBG code. This is important because some cities can be can have the you can have like their names written wrong on the internet. So the IBG code is the best way to combine them. And then you do some cleaning. You choose only the city, the state, the area, the area and the population, and then just rename to be more interesting. So at the end, you have this data set, but you have problems. You know, you have spaces in the numbers, you have commas in the numbers because the decimal separator in Brazil is comma, is not point, and R understands the decimal as a point or a dot, and you have spaces in population. So they learn how to clean this data, how to replace spaces, how to split for nothing, how they replace commas by for dots, and how to transform everything in numeric data. At the end, you have a clean data set that can be analyzed. For example, you can relate area and population and see you don't have a linear relation, for example. And they can make some exploratory data analysis or some modeling in the data set they just got from internet. So this is what I had to show to you today. I passed 1 minute. I'll ask 1 minute more just to say to you the student evaluations for this course are great. The students write very nice things about the course. They say they feel they are prepared. They are learning a lot of things. Even the things are taught only on a superficial level. They have like the starting point. They know the model exists, so they can do their own research to be more proficient in this modeling. 2019, last year, was the first year the course was offered outside statistical department. I gave this course to the actuarial science department, and the reviews are great too. The students really liked. And we have future plans for this course. For example, we never have time to go to, for example, deep learning or time series analysis or LSTMs or neural networks. So a two-course semester will be great, so we can teach the students more models, more different models. And everything is free. You can get data, you can get software, you can get everything for free. And thank you very much. Sorry for I passed 2.5 minutes. I hope you enjoyed. Thank you. Of course, and these are the reference if you want to take a screenshot or anything. Okay, thanks.
Thank you, Professor Marcus, for sharing your classroom projects and data sources with us. Your idea of web scraping is wonderful. We can use in our classrooms this. Our next speaker, should we ask for question answer session at the last? Professor
Yes,
Marcus?
let's have a discussion at the end.
Okay. So I will call next speaker.
Yes, please.
Oh, thank you. Thank you so much. Our next speaker is Professor Leonardo César Teonácio Bezerra. If I am pronouncing right, I'm very bad in pronunciation. Professor Leonardo Bezerra is an assistant professor at University of Federal do Rio Grande do Norte in Brazil. Over the past 5 years, he has taught problem solving through computational thinking and data science to non-programmers. His research interest spans over optimization and learning with a focus on automated algorithm engineering and multi-objective optimization. Please, Professor Leonardo César, join us and share your views about the title. Over to Professor Leonardo César.
Can you hear me?
Yes, very clear.
Yeah.
Okay, thank you for the introduction. Thank you for the invitation to take part here. I'm a bit less familiar with Zoom than I am with Google Meet, so please bear with me while I try to share my presentation with you. Let me know if everything is working correctly. Can you see my screen?
Everything's correct. You are full screen and everything is right.
Okay. So I also don't know if you can see Marco's face here because I don't know how to. Okay, maybe this is better. So let me start introducing myself. I was invited by Marcus to take part in the book chapter that is about statistical learning approaches for developing countries. And for me, this is a pleasure because I really like to share with you the experiences we're having here. So in a nutshell, the chapter was described as an active and agnostic approach to multidisciplinary statistical learning, okay? And then the emphasis are on these three words, probably, active, agnostic, and multidisciplinary. So let me see if I can convey these principles and why they were important and why we were using them, okay? So let me start just explaining where I come from. Yeah, I'm an assistant professor here at the university. So we give you a lot of hard work to pronounce our names and the names of the universities, but you've probably been there all over. So my name is Leonardo Bezerra, and it took me 4 years to learn my supervisor's name, and he never learned mine, so it's okay. Basically, I come from UFRN in general, so this is the university where I had my undergraduate course and also my master's, and my PhD was from Université Libre de Bruxelles, ULB in Belgium. And basically, I try to summarize in a little small word cloud what I do here, which is basically machine learning, programming, hackathons, and this kind of approaches. So as to teaching, I've been basically teaching problem solving through computational thinking. So that can be like an entry level course, like for people who are just starting in the topics in IT, or that can even be for advanced courses in the IT curriculum. Okay, so it depends on the general topic is this, but the level of the course varies as a function of the groups that I have. And this is something that I've been trying to do also on the topics where I both teach and research, which are computational intelligence and data science. So these courses are courses that I prepare that should be valid either for a short-term course, like an 8-hour course, or for a 60-hour course in an undergraduate level or a postgraduate level, graduate level. So I only choose the level of the course as a function of the students that I have, of the group that I have, but the principles are basically the same. Specifically, these last ones on data science, which are the ones I'm going to talk to you about here. So where did this come from? So I started doing data science because I work with computational intelligence, and if you're a researcher in an area that depends on data, you've probably been there. You have data that you need to analyze. So you can either be fighting to produce data or fighting to analyze the data, right? So in my master's, I was fighting to produce data because computational power is a big limitation in developing countries. And this was the case for me because this was simulation-based research. And producing data was very tricky. So I focused a lot on this, and I learned a little about data analysis. Then I went for the PhD. I had a computational cluster at my disposal. So producing data became much cheaper, but then analyzing data became much trickier because now I had the room to learn a number of approaches to analysis. And back then, I think I used very little of what I was able to learn after the PhD because data science is absolutely multidisciplinary, and this is something that motivates me into these courses as I present them now. I was from an application domain. I was from computational intelligence, from heuristic optimization, something that is very specific to IT. And I didn't have the background on statistics that was strong enough to allow me to analyze the things as I would like to have. I actually did a lot. I learned a lot. But after I finished the PhD, I kept on pushing towards learning more about statistical analysis. And it helped me see even further in what I had already done. And basically data science is always like this, right? You sometimes in a team have someone that has a strong statistical background. You have someone who has strong business insights, and maybe you have someone that does some IT advanced programming of the things that you need. But often you also just have one person that has to deal with everything. So the two situations are not ideal, because in the situation where you have one single person, that person cannot be optimal for all the three tasks. And in the situation where you have three people that come with different backgrounds, you usually have a big issue that is communication, right? So it's not about the language, it's about what you're trying to convey, because people don't understand each other's background. And for me, the most significant issue I saw with courses on data science and statistical learning in general is that the multidisciplinary nature of practical projects was not being conveyed in the courses. Because if you take the course in a statistics department, and Marcus gave you as a great example of how to change this, but in general, the traditional approaches would be that you focus on the statistical methods. If you take it from in an IT department, it's going to focus on programming libraries. My kids are joining the chat. Welcome to the pandemics, right? Our home offices are also our daycare centers. So if you're taking this course in an IT department, what you're going to have is that the courses will probably focus on programming libraries and advanced techniques. And again, it's going to be far off from very important aspects such as data processing, of understanding the questions you're trying to answer, understanding the application domain you're dealing with. And then if you go to business, it's probably going to see it the other way around, right? You have a lot of business insights, but the techniques that are going to be used, they're very limited, either because IT is required or deep statistical knowledge is required. So for me, I see silos, and I wanted to see how can I got these people come together. And the first challenge is that in the university, it's not very easy to make these people come together, because courses like the curricula are made to be, in a sense, isolated, right? So I had a student who wanted to take a course that was being offered by Marco's department, but then all the prerequisites for that course made it clear and crystal that he could not take them. Not because he didn't have the background to do it, probably, but just because the curriculum is made like this. And even if the curriculum is not made like this, sometimes the professors have this kind of understanding that if the student came to this course, they should know this, this, and that. And what I was trying to do is that I want to reduce this. And the second thing is, okay, so if I can reduce the requirements for students to join the course, then I still need something, which is they have to be motivated into taking part in this. So in STEM courses, basically you generally have this approach that is based on keynotes. And in non-STEM courses, you have approaches that are much more active and interactive and social, for that matter. And you cannot make one world bridge with the other, because you take STEM students and you try to make the courses more interactive and more social, and they find it odd, at least, especially if you go to IT courses. And if you go the other way around, you take non-STEM students and you're just giving keynotes, they're gonna be deeply frustrated, right? So the principles that underlie this, and there are a lot of images on the right side, I will talk about them gradually. So the principles are, I need these to be based on active learning. And here in Brazil, active learning is strongly represented by the book Pedagogy of the Oppressed by Paulo Freire, and also other books that he has, and a lot of educational theory that was developed based on this. And of course, outside Brazil, there's a lot of literature on these topics too. But basically the idea that education is necessarily political, in the sense that if it does not involve the world that surrounds the student, then you're making a simulated environment that is severely restricting the learning process, right? So the idea is I want the students to be able to integrate this into their world, like Marcus was saying about using real world data sets, for instance. And the other thing is that critical thinking has to be very, very strong. So it's not just about like, this is a book from the 60s or 70s. So understand that in that context, it was even more important about not just conveying information, but actually getting the students to develop critical thinking, which unfortunately in the context of STEM is still fairly limited, fairly limited, even if it has advanced a lot. But basically the curricula are still very content oriented, in the sense that you will learn a very significant number of techniques, but very rarely you understand the application context where those techniques will be necessary, and even more so the implications of the applications of those techniques. Okay, so because of that, I also I really, you see that I like old literature, right? I always refer also to How to Lie with Statistics, because maybe for statisticians, this is already like too old, but for every other people in every other area that have never come across this book before, it's impressive how they only find out the date of the book because it's actually written there. Because if you just take the examples and you tell them in the classroom, it's like you're talking about last week. So active learning is, in this case, I try to implement it based on two pillars. So tutorials and problems. So the idea is that the students, they are divided into groups, right? And each group has to present a tutorial, and each group has to present, to develop a project that they have to present. And the idea with the tutorials is that I want the students to learn together as groups, in the sense that they're gonna convey the information in a level that is more understandable to them. I know that the role of the professor is in general to make the complicated turn simple, but I also like to do this from the perspective of the student, in the sense that I want to see what is their take on those topics. And then my role is like in these tutorials is to deepen the discussion and to sharpen the discussion, in the sense that if they have poorly understood some concept, I can help them refine this view. But basically, they should present the tutorials. So I'm gonna show you an example. Once you have the course curriculum defined and you have the tutorials planned, the students know that they should prepare a tutorial on that topic, like they were going to present in a conference or in any kind of workshops or events, the community events that they could attend. And this is one of the benefits of the idea, that they get material that is now ready to be presented somewhere else. So now, for instance, we have the Brazilian Python conference that is going to happen in November, and some of my students are going to present there, because basically they've been preparing this for the course, so they can just reuse them, right? And in the project part, basically they're applying this. The only thing I ask is that I say, okay, the application domain, you have, it's actually called a generator topic, right? So it's just to situate them. So in a data science course, for instance, it could be web scraping, like Matthew said. So you want to work with web scraping? Okay, I'm not going to tell you what you're going to do with web scraping, but the project has to be about web scraping. Actually, I use 2 pillars there. They have to choose one topic, and they also have to align those topics with the sustainable development goals from the United Nations agenda. So they understand that there's a social impact from what they're doing, right? So basically, this is the idea. The course runs as alternating weeks, in which in some weeks the students are presenting tutorials. In other weeks, they're presenting how they advance with their projects. Okay, and then the second leg, in which which underlies these courses, is the idea of IT agnostic learning. So the active learning is to say, well, I can motivate people to come, because it's not going to be a traditional sit there and listen to me talk. Unfortunately, I'm sorry that I'm talking so much in this presentation. I like to be interactive. So it's not about me talking all the time. It's about them interacting and promoting a learning environment. And then the second part is if they're motivated to come. So if I think I can motivate non-STEM students to come, they need to come and be able to complete the course. And that's where IT agnostic learning comes in. And the idea is I try to use as much as possible graphical user interface applications, such as Google Forms, Google Sheets, and Orange 3 for data mining. So you're probably familiar with Google Forms and Google Sheets. So Google Forms for data collection, Google Sheets for anything that you can do with a spreadsheet application, right? So for IT students, it's actually very interesting that they start finding out that they can do things with spreadsheets that they didn't know they could. And for non-IT students, this is really the middle ground. And I was saying that I started learning this necessity for IT agnostic data science when I was doing the PhD, but it became much stronger when I came to work here at the university, because I was invited to join a project that was supposed to review the undergraduate course classification in Brazil. It's based on the United Nations classification actually it's for any level of education, but here we were working just with undergraduate studies. And basically we had a team of 25 people that had to review the classification, like to adapt the international revised version of the classification from UN to the context of Brazil. So we had to respect some international comparability criteria at the same time that we were trying to adapt this to our context. And it was like 70,000 undergraduate courses in Brazil. And there were 25 people involved in this project, and only 3 had an IT background. So we were talking about 10 different knowledge areas in a team of 25 people. The most advanced IT tool I could use was actually spreadsheets, and even using Google Sheets, which was trying to help them so that we could have an online collaboration, was not doing the job as it should, because people still thought they felt more confident downloading the spreadsheets, working offline, and sending the spreadsheets back so that someone would integrate this back into the original spreadsheet, into the online spreadsheet. So you see that the job was really tough. And there I understood to a very significant level the difficulties of working with people from several different contexts in a real world data science project, right? So that's why I'm trying to push for this. So when I teach students and I talk about Google Sheets, I always say this, you know, when you're in a real world data set project, most likely the most advanced IT tool you're going to be able to use is a spreadsheet. So it's a like a, how can I say, it's a game changer for the students, both IT and non-IT. And I can make this even more general, like STEM and not STEM, because STEM students are generally use it to more advanced IT tools, and non-STEM students are generally are less digitally literate in this sense of very specific tools like all the other ones that we have here, right? So Orange 3 also helps a lot. So basically, Google Spreadsheets serves as a middle ground, and Orange 3 is already something that allows them to do some kind of data modeling. So you can do basically data collection with Google Forms. You can do exploratory data analysis with Google Sheets and also Google Forms because it has a nice summary in the end. And Orange 3 helps on data modeling. And then I also try to get them into the world of computer programming, but from a perspective that is so high level that if you understand the basics on computer programming, the courses cannot have any requirements for understanding structured programming. They only use command line interfaces, like the same as engineers would do with AutoCAD, or statisticians would do with maybe stats, I don't know. I mean, anything that is not requiring them to run loops or to make decisions, like to have if else's or any kind of this. So the whole courses are just, if you understand the basic or command line interfacing, that will do. Okay, so they're to make that clear. Why is that necessary? Well, a lot of the advanced IT tools are still constrained to programming libraries, right? So pandas for data analysis, scikit-learn for machine learning, for instance. I'm talking about the Python universe because for me, it's easier to bridge this, to cross this bridge with the students using Python. And then to make this less, how can I say, less challenging for them, I go for Colab. So Google Colab is an interactive platform that they can use. Here, I also listed Jupyter. Jupyter is the offline version of Google Colab. Okay, let me pay the due respects, right? So give the appropriate credits. Jupyter is a project like for interactive programming that is very interesting. And because it was so interesting, but generally use it offline, Google created a version called Google Colab. That is an online version of this. A few differences, but basically they're the same. So it works like Google Docs to a certain level because the interaction is not as advanced as it is in Google Sheets, for instance, but still you can do projects together. So the idea is I try to move them from basic graphical user interface applications, passing through Python libraries using Colab as the platform where they can run this. And then at the end of the presentation, I can show you the repositories that are available as free online courses that the students helped create. And basically that's it. They go there, they take the courses. When possible, I'm trying to broadcast live streamings of these courses also. So videos are available. And this is how the students should try to survive in this world, right? But still, to make sure that this works, every beginning of the semester, I do student segmentation. So I analyze the background of the students and I try to assign them to groups in a way that is, I ask them to collect data about themselves. And after we collect that data in the first day of class, I show spreadsheets as a practical approach to do a basic exploration. And I use orange mining to do clustering and say, look, these are the profiles we can see in the class. Let's try to mix these profiles so we can have groups that are balanced, right? So IT, non-IT, STEM, non-STEM, more free time, less free time, more advanced into the curriculum, less advanced into the curriculum, and so on and so forth, right? And all these are available as also Medium posts. So all this that I did with the students, I can provide them beforehand to say, read that, that's what we're gonna do, and we can do that. So this is the pilot project that is happening in northeastern Brazil. And understand that Brazil is a country that has a lot of struggle with education, but the northeastern part in Brazil is among the most poor parts. So here we're not discussing about digital literacy. We're not discussing about second language literacy. We're really discussing about literacy at all, okay? So it's a very challenging context. At the same time, we have students that are, I mean, social inequality is so strong in Latin America that you have students that are like at the final for the world programming competition from ACM, the programming marathon from ACM, if you're familiar with it. So in the same university, you have these students that are like getting internships at Facebook, Google, Microsoft, Amazon, and students that join the course and they have had very little contact with uh, digital tools in general and computer programming even less, or computational thinking even less. And I'm talking about the IT course. If you go for non-STEM courses, that's even stronger, right? So we were able to hold some courses here. So at undergraduate level, I hosted a one group for data science and one group for machine learning. And for graduate level, I hosted 3 groups for data mining, but actually I run them as data science, so it's pretty much the same. And then here I cannot say like STEM and non-STEM, because even if we're doing the best we can to get non-STEM students for these courses, the limitations in the university requirements still made that STEM students from engineering and other areas that were not IT students were able to join, but the others still were not. But still, we get a lot of, we've had nearly 25 students that were able to take these courses. They don't have an IT background, so I cannot expect them to be advanced into computational thinking abilities or computational science in computer programming in general, and they succeeded in the courses, right? And just a quick example how it worked. Basically, the skills are on the left, right? So what I expect them in the machine learning course to learn is understand pipelines, evaluate pipelines, and apply pipelines. Then for unit 1, there's a discrimination of like the tutorials that they have to present and the projects, like the deliverables that they have to give. And then on the right is only the domains that they had to choose. So your project can be anything as long as you choose one of these topics and you also select development goals from the United Nations, okay? And then more recently, this is not in the book chapter, but I was actually able to run a course that was mostly for law students. So it's data-driven decision-making, where I was showing them how the decision-making process works. And I was saying that, for instance, for topics 2 and 3 there, like collect information and identify the alternatives, I was showing how to use data science to do that. And for topics 4 and 5, like weigh the evidence and choose the alternatives, I was showing how to do that with multi-criteria decision-making. And the interesting part is that we had, I think, 20 people there in that course. And sorry that this slide is in Portuguese, but it was a graph that I could not translate. But basically, if you look at their background, so that's a histogram showing the background. The first group is business, administration, and law. And the second group is IT. So only 4 students in this 20 people group were IT. And all of the others, or most of the others were from several different areas. So social sciences, journalism, health, well-being, and then there are some people that are in engineering, so they understand a bit better some things. But still, this was a course that was about data science and statistical learning, and it succeeded perfectly without people really knowing how to program. Of course, for this one, I didn't go into the Python libraries because it was an 8-hour course, but if it had been a 60-hour or 30-hour course, for sure, I would have gone into that. So basically that's it. Thank you for your time. I'm sorry that I probably exceeded it a bit. And if you're interested in seeing where this is available, I think, can you see this screen too, or is it still in the slides?
Yes, we can.
Yeah, so basically on my GitHub, I have like Panda 0. So Python 0 for people who are starting on Python, if they do want, because if they don't want, they can go straight to Panda 0. Scikit 0 for scikit-learn. Data science 0 is there too. This has no programming at all. And also we're trying to go into deep learning now, so Kara Zero. The idea is that all this should be made in a way that is only command line interfacing. People come here, they choose, let's say, Panda Zero, they go for English. And then they choose one of the topics that is here. Some of them have videos on YouTube. And as soon as they click on Colab, it's gonna launch and they can basically start learning. Of course, Panda Zero assumes you know nothing about programming at all. Scikit Zero assumes that you took the Panda Zero course, so it goes a bit further. But basically, you just run this and you start learning indirectly about computer programming in a level that is enough. Okay. Well, thank you again. Sorry for extrapolating my limit, and I'll wait for the discussion.
Thank you, Professor Leonardo, for sharing your views how we can improve our statistical learning experience. You are right, we must change our teaching mood from lecture and listen format to one that engages students in active learning. No doubt, appropriate computer-aided tools can stimulate students' interest and cultivate their experimental ability. Now, I would like to invite our third and last speaker, Professor Monde Uzaji Adinomon. Professor Dr. Monde Adinomon holds a PhD in statistics with specialization in financial time series analysis, and he is a chartered statistician. He is Fellow of Royal Statistical Society, Fellow of African Scientific Institute, and member African Evidence Network. Presently, he is serving as a senior lecturer in the Department of Statistics, Nasarawa State University, Kefi, Nigeria. Professor Adenoman is the founder of Foundation of Laboratory for Econometrics and Applied Statistics of Nigeria, a foundation that supports and mentors girls, women, and indigent students to achieve their dream in the field of mathematical, statistical, and data science. Professor Adenoman is also coordinator of NSAKISA Stat Lab and consulting statistician. His drive is to mentor Nigeria youth to move from theoretical education to practical and fulfillment. Now I would like to request Professor Adenoman to join us and share his views. Over to Professor.
Okay. Good afternoon, everyone. Can you hear me?
Yes.
Please, can you hear me? Okay. Please, my network here is unstable, but I'll see how far I can go. But as a result of that, I'm not able to use my video, but this is me. This is me. But I'll put off the video because of the network. Okay. Well, I'll be talking on the topic, teaching and learning statistics in Nigeria with the aid of computing and survey data set from international organization. Okay. Let's show my okay. Okay. This is the outline of the presentation. Look at it. We're going to introduce it, the aim of the paper, look at the challenges of teaching statistics in Nigeria. We look at cost of some statistical software. We look at R and some of the packages. We look at sources of survey data sets. We can look at teaching and learning statistics using the frame called the team. And then we'll draw some conclusion there. Well, statistics education first started at the University of Ibadan as far as 1957 to 1973. But still, the educational statistical education is still very low in Nigeria. If I'm not be too, especially in our region here, the northern part, the statistical education is still very low. According to Adelodu and Aware, stated that the major cause of low development in statistical education in Nigeria is lack of understanding of statistics education as a separate discipline among educational sector or stakeholders in Nigeria. Actually, many times statistics department are always often merged with mathematics. Many times mathematics will start first, then maybe statistics will be embedded into it. But most of the time, if statistics is not separated, if statistics department is not separated from mathematics department, before you know, mathematics department will be overshadowing statistics. That's why in my university, we used to be with the mathematical science at the department in 2018 or so. We splitted to different departments. We splitted to computer science department, statistics department, and mathematics. And with the split now, it's making to do well, at least as a lecturer in that department, and also to focus more on our students. Well, the aim of this paper is to establish the platform to discuss this framework called TEAM. But this TEAM is, from my experience when I joined the university, I used to lecture in Polytechnic before, and I joined the university in 2016, towards the end of 2016. And I felt that if this frame is used, we can do well. It will help in teaching and learning statistics in developing countries like Nigeria, or such as Nigeria. And again, the computing aspect also, which I will dwell more later, you see that sometime later we'll dwell on that. The packages we use, like the SPSS and all that, they could be expensive. And just unfortunately in our country, sometimes you can have some cracked version and all that. But the data survey is also available free. That's what we are going to dwell more on, how we can use R to better teach statistics and also use the TEAM frame to drive home to influence our students more. Now this is just some challenge. Some of the authors have added to they have specified as challenges, like Okunloye 2014 revealed that teaching statistics as part of mathematics has not helped the development of manpower training in statistics. Yeah. Even in the secondary school, the statistics is embedded in mathematics as a subject, but we don't have a separate subject to say, okay, we have mathematics as a subject and statistics as a subject. And that has also affected, because sometimes the awareness of statistics among the secondary school or college students, they're not really aware of the adoption of statistics is also inadequate and all that. But look at the most of the things I found from experience. Number one, lack of real-life application. Sometimes statistics is taught without real-life application, especially when it comes to statistical theory, probability. If one takes it from the abstract to the practical, the student seems to appreciate such. Then we also have the problem of lack of computational application, both curriculum. Like I must say here that we started using R as I got to this university in 2016. We started using R in that place in 2017, just very recent. All the same thing, the students are picking up those ones we met on Grande. they will have another major problem of lack of mentoring, because later we'll see in our case here in Nigeria that even in statistics, sometimes people that apply for statistics are few. Sometimes more of our students come from other background, meaning that maybe they apply for computer science or they apply for one other course. If they can't find those courses, they can't get those courses, they can admit them into statistics. Therefore, since they don't have interest at the initial, mentoring is very important. But problem of lack of mentoring is also there, lack of creative ability, lack of computing facility, lack of interest by students, and teaching statistics, making it theoretical. Sometimes students will be asking, and they're just telling us their mind, telling us that although the theoretical part is very important, but there should be we need to embed real-life applications so that they'll better understand what you're trying to teach them. Actually, this is a survey I carried out with my final year students. The students are less than 30, but these are the few ones that came to the lecture that day. I designed a questionnaire, and one of the questions is that, how many of you really applied for statistics? You can see that 10 of them say no, while 7 of them say yes. Although this number seems to be few, but it's just a picture of what is evident in Nigeria, and most maybe developing country like Nigeria also, that people that apply for the course are few compared to those that apply. That's why the need of this framework will help catch them young and then keep them in the field of statistics. Okay. Now we'll come to challenge the course software. We have many of them. We have the eView, we have the Minitab, we have the Stata software, but they are very, very low in the use of R. Even I myself, I started using R when I started my PhD in 2011. I started using it around 2012 or so. And the cost, you can see the cost. If you want to get the real license, you see the cost here about this dollar, about this amount in Nigeria. In a nutshell, this software can still be available through different medium, but we want to see, since R is free, and not only that, data sets in some of these websites are free, it will be important for us to encourage the student to use R and also be able to use those data sets from those free webs, the World Bank, UNESCO, and all that, UNICEF, and all that. Now for R is very, very, very useful, especially in developing country like ours, because it's free. The packages are free. You can easily learn them using some of the what I call it, the handouts, the handout. Sometimes the arrow, those that develop a package or develop an handout that students can use, and you can see the abilities of R. Can perform this and all that. And these are some of the packages, apart from the basic, these are some of the packages we can also use in R. Okay, we look at, okay, let me go on to the sources of data sets now. Like we have the National Bureau of Statistics, they also have their data set free. But sometimes, although we are closer to the headquarters in Abuja, there's sometimes the data set, they may want you to also come down to extract it from their book, maybe because they don't have much of their data set online. But those other ones they have online, we can also access it. This is a source of data set for student projects. And most of our students are using data set from this National Bureau of Statistics because it dwell more of data cases for Nigeria. They use it more of their work. You see them use data set from MBS and all that. This another a public microdata series called the INPOMS. Well, I got to know this when we attended a conference at Malaysia. That is 2019. Yes. In fact, I attended some of their what I call it, like a lecture, and I found that these data sets are also very useful in teaching real life, in teaching statistics in Nigeria. They will also have this DHF for different countries. Like where I've used this, one of my students work on malaria for pregnant women. We use data set from this. One of my students also work on contraceptive. We use data set from this website, and they are free. It's free of charge and very useful in teaching and also for projects. The another one that is of interest to me now is the UNICEF MI. That is the mix. There's they call it what do they call it now? It's indicator cluster survey. And this data in this place you can get data set on maybe immunization, nutrition, especially for developing countries. One of my students we are using a data set from here on utilization of in Nigeria. We're using the data set in teaching statistics and also learning. The frame of Eric and Smith. The Eric frame it has been very useful in teaching statistics. But in our context here, North Central Nigeria, we're trying to use this team in teaching statistics, and the teaching statistics is also consistent with the objective of the International Teaching Effectiveness Colloquium series established in 2005. This is from Cochrane 2010. Teaching statistics for people to better understand, learn, and know that is consistent with what before now. That means we are on the right track in teaching statistics for better learning. Now, the T there is teach and train. Now, teaching is very important. Recently, a student of mine was trying, we were teaching them. We're not just lecturing them, but we are teaching them. Sometimes the students they differentiate between teach and lecture. They define teach means that to allow to fit with, because most of them don't have good background. Teaching them, they understand it and they will be able to apply it in the real world. And this is some of the training. These ones are Please, I have unstable. Hello, please, are you with me? Are you with me? Hello?
Yes, please.
Yeah, we can
Hello,
hear.
are you hearing me?
Yes.
Yeah.
Are you hearing me?
Yeah, we can hear
Yes,
you.
we are.
But
Yes, we can hear you.
Yes. Yes. I can.
Speak on, we can hear you.
Hello? Hello, are you there?
Yes, go ahead.
yes,
We can hear you. Go on. Monday, go on, we can hear you.
Hello?
Yes, go on, we can hear you.
Now, come to the teaching, as I mentioned. Yeah. Thank you. Now, teaching, we try to teach this because most of them have low back, they're not the background is in mathematics is very low. We go down the try to teach them to understand in use in and all that. When students using computing or calculator interest, meaning that is to the real. Okay. Interest of the students. Some of them prefer applied statistics, more also prefer computational statistics. Though few of them prefer theoretical statistics. Very sorry for the bad network. Okay. Meaning here that people here want application of statistics to the real world, and this one we use it to teach them. Apart from that, also some of these topics like probability distribution, we use R to teach them. Sometimes they want to ask you, what is the difference between a distribution from a continuous random variable or a continuous random variable and that of discrete? We try to teach them and say, okay, most of the time when it's a discrete, you see that it follows, is a count. When it's a continuous, like a measurement and all that. Okay, then attitudinal influence, very important. Here, we're told, we've established that statistical education, even mathematical education, is very low. And many persons, as I mentioned before, they never apply for statistics. And sometimes when they come to statistics, you need to influence them to remain in statistics. Use your own story. We use our own story to teach them, tell them that statistics is very is an interesting course to study. We use our experience also to influence the attitude to remain in statistics. Like the man here, as I mentioned in my previous presentation, this man, about 60 years old, came for PhD statistics in experimental design. We were able to influence him, and he was able to go into financial time series analysis. Eventually graduated. Now we come to mentoring. Now mentoring is very important when teaching these students. Mentoring is very, very important. Sometimes, just like as if you are picking them, although they may not be too good as you expected, but by mentoring them, you see them coming out doing well in the future. Like this first picture, I'm trying to mentor this our undergraduate students. I'm trying to mentor them on how to use R. Although these are like some of the girl here, we have two girls here. This girl here was giving me the story that she was not doing well in 100 and 200 level. But when I met her in 200 level, 400 level, and with mentoring, she graduated with a second class. These are my PhD students. Sometimes, sorry, my MSc student, postgraduate student. Sometimes they ask questions that to you expect them that they must have learned this at 100 level in their undergraduate. But unfortunately, they don't have that idea. Mentoring them, these are my mentor classes. You can see them, they are ready to learn. And when you mentor them, you see them doing well in the future. Okay. Now, as my survey from undergraduate students say, how many of you desire mentorship? Majority of them desire mentorship. I'll try to ask them, okay, do you think that mentorship can, if you mentor them, there's possibility that academic performance can be improved? Okay. To conclude, although this term is still underused, but we therefore recommend that the use of STEM frame can help improve teaching and learning statistics with the aid of computing and also using survey data set from this international organization. These are some of the bibliography. I wish to thank these persons, and I wish to thank every one of you for listening. Thank you very much. Thank you very much.
Thank you, Professor Monde or Denard. Your idea of team is really wonderful, and it can be very effective for teaching statistics. You have mentioned very good sources of data that are available for almost all developing countries, that is makes a demographic health survey. Thank you so much. Now, session is open for the questions. Participants can ask questions to all the speakers.
Hello, can I speak?
Yes, sure.
Great. I want to thank all the speakers and the moderator as well. I think this is a very useful and very valuable session. I mean, the question that actually came to my mind is, since this session is new approaches to statistical learning in developing countries, so I'm bothered about how we define developing countries. Having listened to Marcus and Leonardo, I think we need to further categorize developing countries as far as statistical learning is concerned. It appears we should have advanced developing countries and less advanced developing countries. In my own part of this globe, I think I want to say we are still in a less developed developing category. And I'll give you few challenges that we face as far as statistical education, statistical learning are concerned. In a typical statistics department, you are likely to see a lecturer's workload to be very, very high. And when I say high, let me give you the kind of things you say. A lecturer would likely take about 4 to 6, sometimes 8 courses in a semester. May have about 16 to 20 hours of teaching per week. May have about 15 to 20 hours of administrative meetings, departmental meeting, faculty meeting, senate meeting, all manners of meetings per week. About 12 to 20 hours of meeting with project students. And then when it comes to this class size itself, you will be surprised that you can have up to between 100 and 1,000 students in a class, particularly in year 1 and year 2. Coupled with infrastructural deficit, and you likely going to see students struggling for seat and space to write. Internet connectivity is poor. In fact, from today's presentation, you will see that only Marcus and Leonardo are from advanced developing countries. It's obvious that Adenomo is from my own part of the world. So if you look at all of this, lack of computing facilities are there. And there are other issues like unstable academic calendar. But you see poor curriculum, the way curriculums are designed. One course can be loaded with a textbook content. So these are the challenges. How do you, Marcus and Leonardo, and how do you now want to, how are you, your proposals, how can they fit into this complex, situation of the less developed developing countries? Thank you.
It's a great question, Olu. Thank you. Well, what I talked in my presentation was related to the reality I know in Brazil. I've been in universities in only 2 countries, the US, where I did my PhD, and it's a different, totally different reality that we have here in Brazil. And of course, I know Brazilian universities. I don't know about what Leonardo will answer to you, but for me, the proposals I made, of course, they need internet, but they don't need a fast or a stable internet connection. The code I show in my presentation, you can run in it's in my computer. It's running like 30 seconds. Of course, I know I have a good internet connection, but it doesn't need to be as good as an internet connection for video or audio. So I think the proposals we made, they could be used in, like you said, least developed countries. When I think about developing countries, I think about Latin America, Africa, and most part of Asia. And I really don't know your reality. I've never been to Africa, and the only country I know in Asia is Malaysia, because I went there last year with most of you guys. But I guess the proposals, at least the ones I made, the ones Adenamon made, they could be applied in least developed countries, because the software is free. The price of S or SAS, and well, R is free. You can download it for free. If the students don't have the internet in their homes, they can go to the university and get the installation files in a pen drive, for example. And I guess it's possible to do. Of course, the workload you have, it seems it's a lot of work in when you count the research, the lectures, the administrative workload you have. But maybe it's my privilege saying this right now, but I think we need to start somewhere. When I started this course in Brazil, this introduction to big data, and just a parenthesis here, the course is called Introduction to Big Data, but this is just marketing, you know. We don't work with big data because our computer labs cannot hold big data. You know, we have like 8 GB RAM computers, so the students cannot work with big data. So it's just a marketing idea one of the professors had at the time, and I thought it was a good idea. But I mean, the things the students learn in this class, they can scale for large data sets. But I think you need to start somewhere, you know. I think if we never start to show this stuff to our students, maybe they will not have the opportunity to learn it somewhere. So one thing you can do, well, it's one thing I do. For example, in I'm giving a class for a master's course in geophysics this semester, and I have this big data course I told you before. One thing I the students to do for their final project is entertain me. You know, it's, of course, this is off record. It's not written in the the definition of the project, they need to and show to me this is important to them, or how this is important to the world. So I think it's not easy, of course, but I think it's possible to do even in least developed countries, like you said. Leonardo?
Leave there now. What do you want? I'll give you later. Leave. So we'll go to church. I'll give you sweet to go to church.
Okay, thanks, Marcos. I think Adesanya has a very good comment on this, and what I can tell you is that I've been to Africa, not continental Africa. I've been to Cabo Verde, and I've been to Europe, and I've been to the States. I haven't been to Asia, and I haven't been to Oceania. But what I can tell you is that I've seen very different realities in the world, but I've seen that what I've seen from Africa and what I've seen from the countryside where we live is very similar. It has a lot of similarities. So to that sense, in that sense, the students that we get here at the university is completely, how can I say it? It's a separate world because it gets funding from the federal government. So it has a level of funding that is completely different to what we would have here if we were to rely on a state or city level funding. So that makes a big difference. Even the professors in the university come from all over the country, like Marcos, or other parts of the world. But having said that, the students do not come from this context. And it's Marcos and me, we are extremely privileged in the sense that in the Latin America sense of the word. So the word is, in Latin America, the word that best describes it is exactly social inequality. So we have this thing here that Marcos and I probably have very good internet connections, very, very good. And most of the students won't have them. So even now that we're trying to have remote classes, we're having a lot of trouble with students that don't have access to computers or don't have access to internet. Furthermore, in the specific case of Nigeria, you do have one thing that goes, that makes it a bit easier for you than for us, which is that even if internet connection is not very good, it's probably less structured in Nigeria than in here, but access to English literacy is probably much higher in Nigeria than in here, because in here we have like 5% of the country with a reasonable access to English. So as I was saying, it's a problem of having Portuguese literacy, mathematical literacy. We do get students that get to the university and they don't know the basic mathematical operations. If we had to have another talk, it would be on how to use computational thinking to improve the students' learning of math, because they get to the university with a very restricted knowledge of math. So Brazil has a lot of different realities in it, and maybe we're talking about old data science presentations. The presentation on Mind Gap that is on TED Talk, Gapminder that is on TED Talk. It shows the inequalities between the countries, and when it shows Latin America, the presentation is exactly like this. See, Latin America has all the continents in it. It has Africa, it has Asia, it has Europe, so everything is in here. In that sense, I think that if you have the resources that for some reason of social inequality Marcos and I have access to, then yes, we can take part in presentations like this with an internet connection that is very good. We have access to computers that are very advanced. The university has a lot of resources that you wouldn't have if you were in a strong situation of difficulty in funding. That is true. But maybe that is something that we should talk in a specific venue. That is how the contrast between where the students come from and what they find in the university makes a big issue. Because what happens is that the professors in the university tend to look at the students and not being able to understand why they cannot understand the concepts that are being discussed in the university. When you're talking about a student that probably had 50% of his mathematical curriculum not completed because he didn't have math professors in the public school system where he came from. Or students that didn't get to attend 50% of their classes because they lived in the rural area and they could not reach the schools that were in the urban centers because the transportation didn't make it. I have students that they take the bus at 5 a.m. in their cities. They come to work in the city. They spend the whole day working. They show up in the university in the beginning of the evening. They stay up to 10 or 10 and a half p.m. And then they take the bus back to their cities and they go to sleep around 1 a.m. So they're sleeping from 1 a.m. to 5 a.m. to come to the university like for 4 hours. And basically we let them sleep because it's completely unfair. So it's a very, very different situation depending on where we go. But I think you're absolutely right that infrastructure plays a significant role in the challenges we're talking about here. Whether infrastructure is access to education, access to internet, access to food, because here in where we live, the schools are basically for feeding the kids. So the parents, they send the kids to school because the kids wouldn't have what to eat in their homes, or else the pandemics has been really, really tricky in that sense because the schools were closed. And the concern of many parents that come from low income families were, what are my kids are going to eat, because they went to school for eating. So all the realities are here. But and when as I said, when I compare what I saw in Africa, not continental Africa, but what I saw in Cabo Verde, and when I see here where our university is located, not in the capital city, but in the countryside, there's a lot of resemblance.
Any other question from the participants?
I'd like to make a comment. So I've been to Brazil, I've been to Africa, I've been to Asia, and that yes, there are very many differences and there are very many similarities, as have been discussed. I can say with pretty good confidence that I think that a course like Marcus's would be possible, is possible, for advanced students in Nigeria. However, a course that utilizes Google Sheets and Google Colab and like online, the IT online infrastructure, that's not possible, in a classroom where students, pay for their individual internet and it's very slow. But downloading R and R Studio, potentially using RNstat, which is a more graphical user interface for R in using in statistics. That could be done if the students, for example, in Nigeria, had a computer, which they have access to computer labs. But I agree also with Marcus that there needs to be some place to start. So we should probably think about how it is that different countries, different universities can start teaching more computation, using more real data sets, having motivating examples for students to really do the interesting things about statistics using a computer, not just pencil and paper, because there are no longer very many interesting questions that you can just answer with pencil and paper. So those are just my comments, that we could definitely start somewhere, in the range of what has been presented today.
Just a quick comment. Lucania is right that about saying Brazil in the question in Brazil as a developing country, because our actual government, our current government, has had an agreement with the United States to give up on the status of developing country. So good that the book is being published now, because if it were like 1 year in the future, maybe we could not use that anymore, Marcos.
Yeah, sure, yeah. The famous OCDE combination with Trump to, well, whatever, let me not talk about Trump and Bolsonaro. I don't like to talk about the subject, and I'm being recorded, so. But you are right, Cleo. Any more questions? No? Are you guys hearing me, listening to me? Oh, Dr. Michael, please, you can talk.
Yeah, hello. Thank you so much, Professor Marcus and other presenters. Can you hear me, please?
Yes, your connection is very good. Your audio is very good.
Right. Yeah, I was wondering if there's any provision from Lisa, Professor Eric, for any complex application. For example, you want to run any complex program, maybe a kind of algorithm, and then you find out that on your local system it's impossible for you, and then you are thinking of for us to rent a space in the cloud. So I was wondering from the Lisa, we can have the opportunity to possibly hook up, get access to maybe the cloud service over there. Apparently, there are a number of other free services like Amazon, and a few other ones. But then most of the time, they don't really give you what you need. So I was wondering if you have that provision at Colorado University. So this is my quick question.
So the question would be, can the LISA 2020 network provide some cloud computing resources for members in the network? So currently we don't have that. And at the University of Colorado Boulder, there is not a program where there's just cloud computing available. So if I wanted to use cloud computing, I would probably I would open an account on AWS or Google Cloud and figure out how to do it myself. So that's not set up yet, but I think that could be a great step in the future where we could get an agreement with AWS or Google Cloud or some other cloud service, and provide cloud computing for the network. I think that would be fantastic, but there are no current plans to be able to do that.
Okay. All right. Okay. Thank you so much. That's a good one.
I would also mention that, I think the folks from Maseno University, they're doing a lot of great work with teaching computation and using real data sets and IT infrastructure. And so they face the challenges in Kenya, that many other universities in Africa face. And so at some point, it would be really good for those folks, for Joyce and Thomas, to be able to contribute, and we can learn from what they're doing in Kenya. We can learn what works and how they started and how they're building on their progress.
Okay.
Thank you, Eric. We'll do that. There are more of us in here. There's a Parker and there's James Musioka. We'll be grateful to have that opportunity.
So we are almost coming to the end of the hour, which is going to be a half an hour after our scheduled time for ending this session. So I'll turn it back to Professor Asifa to conclude the session.
Thank you, Professor Marcus, for organizing this plenary session. We have given you an opportunity to listen the wonderful talk of speakers from the African countries, developing countries, and Brazil, both shares their experiences. And thank you to all of speakers and participants for joining us. I think we are out of our scheduled time, so thank you so much for giving Professor Marcus for giving me an opportunity to chair the event. It is my first experience, and I'm also learning new things under LISA 2020 network. So it is a good experience for me also.
Thank you, Asifa. You were great today. I didn't notice it was your first experience. You were awesome. Thank you, Eric, for your contribution, for asking me, for inviting me to lead this session. And if I can give you one thing to remind from the session, from the 3 talks we had today, is one thing that all talks talked about, real-life applications. Show your students real-life applications, engage them. It doesn't matter if it's too simple for you. Even a very simple application could be something that will inspire your students, that will make them be successful in their professional lives. Thank you.
Thank you. Thank you all. And next week we have a session that is organized by Ezra Gayawan from Futa-Lisa. And that session is, the session is Technology and Multimedia in Statistics and Data Science Education. So it's going to be a follow-up really to this session, where it's what can be useful in the classroom for statistics and data science education. So we hope to see everybody again next week on Thursday, the 5th of November. So long, and thank you everybody for attending.